Taiwan, located in the Circum-Pacific Seismic Belt, has fragile geology and steep-slope mountains. It is located in the monsoon frontal zone and western Pacific typhoon path. During typhoon or storm events, heavy precipitation easily induces debris flow events. The Disaster Prevention and Relief Act, which was passed in 2000, gave authority over disaster prevention and relief in the central government to the Council of Agriculture Executive Yuan. The Debris Flow Disaster Prevention Center classifies debris flow management in 4 stages: disaster mitigation in peacetime, preparedness before the disaster, response during a disaster event, and disaster recovery after the event. The Debris Flow Disaster Prevention Center is in charge of developing a master plan for debris flow disasters. The Debris Flow Disaster Prevention Center is also in charge of conducting hardware and software measures such as debris flow potential area investigation, influence area identification, establishment of a detailed list of preserved objects, emergency response execution, and post-disaster recovery and reconstruction. Whenever the Central Weather Bureau, CWB, issues a typhoon alert, the central government sets up a temporary Central Disaster Response Center. The Soil and Water Conservation Bureau of the Council of Agriculture, Executive Yuan, SWCB, forms a Debris Flow Disaster Response Team immediately. The Debris Flow Disaster Response Team is formed for 3 different response levels that depend on the disaster potential. A 3rd level response occurs whenever a heavy rainfall warning is issued. A 2nd level response occurs when an offshore typhoon alert is issued. A 1st level response is carried out when a land typhoon alert is issued. All 3 response levels of DFDRT require operations in shifts round the clock. The duty staff needs to regularly follow an autonomous checklist. They follow the relevant authorities' orders to prepare for a disaster prevention meeting, give a press release, and notify branch offices to implement disaster preparedness measures, including 1. Putting heavy machinery on standby, 2. Notifying emergency contact people, 3. Carrying out communication tests for all levels of response centers, 4. Doing safety checks on all ongoing construction projects. During the response operations, the duty staff need to continuously monitor precipitation and issue debris flow warnings if needed. If the forecasted precipitation is larger than the warning threshold, a yellow warning is issued. Local governments advise residents who are in potentially dangerous areas to move to designated safe locations. If the observed precipitation is larger than the warning threshold, a red warning is issued. Local governments evacuate residents who are in potentially dangerous areas to designated safe locations. In order to enhance the accuracy and efficiency of response operations, the SWCB has developed Standard Operation Procedures, SOP. Since 2001, information systems have been developed to improve efficiency and simplify operation procedures. The improved information systems include those for debris flow disaster prevention and the response system, disaster preparedness management system, and multi-scale remote sensing and spatial information system. Functional modules are developed based on the SWCB's debris flow disaster prevention and response system, along with warning analysis and issuance of an SOP for assisting in getting out a warning. The information system can integrate meteorological data such as the typhoon path, precipitation observation, and precipitation forecast. This helps to obtain accurate information in a dynamically changing situation when a debris flow event occurs. The SWCB has established permanent observation stations in debris flow prone areas and dispatches portable observation stations and simplified observation stations to collect data. In addition to the debris flow information collected by advanced observation equipment and images transmitted from the satellites. This information allows on-duty staff to do an evaluation and determine whether to issue yellow or red warnings. In addition, a professional team composed of National Taiwan University, National Chung Kung University, and other research institutes provides an evaluation of the warning threshold, based on available information, experience, and their expertise. When the response team issues a yellow or red warning, the warning can be disseminated using the auto warning issuance procedures in the debris flow prevention and response system. Via a step-by-step procedure, the warning notifications are sent to central and local disaster prevention and response centers using fax and telephone. Also, warnings are delivered via media, debris flow apps, Google Taiwan Disaster Response Information Platform, and information delivery methods ranging from text messages to contact through emergency contacts, village chiefs, and required disaster prevention commissioners to be broadcasted over the neighborhood PA systems in order to notify local residents. When an emergency disaster notification is received, the DFDRT immediately contacts local branch offices to handle the emergency situation and fills out an assignment tracking sheet. The local offices then send investigation staff to the disaster site. The staff communicates with the local authorities and clarifies the working scope. After the investigation, the disaster situation is reported to the DFDRT via phone or wireless transmission. For disaster areas that are not easy to reach, remote-controlled drones will be sent to take photos for a preliminary evaluation. The integrated digital database includes historical data on major disaster events and real-time on-site investigation reports. Google Earth is used as the debris disaster management platform to integrate real-time disaster investigation information. The graphic display of the location information provides the SWCB with a good platform to analyze and display the disaster information during and after a disaster. This platform helps the SWCB improve the effectiveness of debris flow disaster management. Taiwan is located in one of the highest natural disaster risk areas. The government should improve not only the capability for disaster prevention and response, but also accumulate past experience to gradually strengthen the autonomy and independently mutual cooperation ability of communities. Via regular evacuation exercises to improve debris flow disaster response, we can integrate the capability of government and non-government entities, strengthen the interaction between community members, establish autonomy disaster prevention systems for communities, improve residents' consciousness of disaster prevention, develop disaster prevention capability for communities, and reduce the overall losses from natural disasters.